You install TikTok, you have 0 followers, 0 watch history, 0 data. Within 3 video swipes, the app already knows you love woodworking tutorials at midnight. That is not a coincidence. That is a recommendation pipeline running on 150,000 GPUs. It must return 15 ranked videos in under 200 milliseconds, every single time, for 1.5 billion users. The engineers who built this solved one of the hardest cold start problems in production ML. Here is exactly how it works. TikTok has 1.5 billion monthly active users. The average user spends 95 minutes per day on the app. That is more than Netflix, YouTube, and Instagram combined. ByteDance's GPU fleet sits at roughly 150,000 A100 equivalent GPUs globally. The recommendation backend processes billions of interaction signals every single day. When Musical.ly was acquired by ByteDance in 2018 and rebuilt with their Volcano engine, average session time jumped 40% in 6 months. This is not a search engine. It is a real-time interest prediction machine operating at unprecedented scale. But here's the catch. Building this from scratch means solving 4 brutal engineering problems simultaneously. Every content platform faces the same 4 walls. First, social graph dependency. YouTube and Instagram's early feeds required you to follow accounts. A new user with 0 follows sees nothing relevant. TikTok's For You page works with 0 follows from second 1. Second, popularity bias. Naive systems show the same 50 viral videos to everyone. Long-tail creators get 0 distribution. Third, latency versus accuracy. Scoring a 100-second model against 5 billion videos takes 5.8 days per request. Fourth, signal freshness. Your watch completion rate for cooking videos changes every 5 minutes. Now here's where it gets interesting. TikTok solves all 4 with a single cascading architecture. Think of TikTok's interest model like a GPS that recalculates every second. Traditional platforms use a paper map, static, built from explicit connections you made years ago. TikTok uses 3 live signals instead. First, an implicit interest graph, built from every watch, replay, like, comment, share, and not interested tap. After just 5 interactions, TikTok's model is richer than Facebook's from 5 years of friendship data. Second, a content graph, videos embedded in vector space so similar topic videos cluster near each other. Third, temporal weighting, what you watched in the last 10 minutes outweighs your entire historical preference. This is why cold start feels instant. Here is the core architectural insight. You cannot run a deep neural network against 5 billion videos for every request. So TikTok cascades. Each stage is cheaper and faster, progressively narrowing the candidate set. Stage 1. Approximate nearest neighbor search retrieves 500 to 1,000 candidates in under 10 milliseconds. Stage 2. A lightweight pre-ranker, logistic regression, or a 2-layer MLP. Cuts that to 200 candidates in under 20 milliseconds. Stage 3. The heavy GPU neural ranker scores 200 candidates in about 100 milliseconds total. Stage 4. Re-ranking injects diversity, freshness, and policy rules in under 10 milliseconds. Output, exactly 15 videos. Total wall clock, under 200 milliseconds. This is why engineers lose sleep. Every millisecond of each stage compounds. The retrieval stage uses a 2-tower neural network. Think of it like 2 translators independently converting different languages into the same shared language. Tower 1 encodes the user, age, location, device type, last 50 videos watched as a sequence through an LSTM or transformer, current session context. Output, a 64-dimensional user embedding vector. Tower 2 encodes the video, audio embeddings from the soundtrack, visual frame embeddings from a CNN, caption and hashtag text embeddings, global completion rate. Output, a 64-dimensional video embedding vector. Similarity is a single dot product between those 2 vectors. Pre-compute video embeddings offline. Only compute the user embedding at inference time. That is what makes ANN retrieval feasible in under 10 milliseconds. Walk through one real recommendation request. User opens TikTok. The client sends device metadata, OS, network quality, location, time of day, plus a session token. The recommendation backend initializes a session context object. It fires parallel recall channels simultaneously. Interest-based ANN, trending content, collaborative filtering, topic-based retrieval. All recall channels complete in under 10 milliseconds. Results merge into 500 to 1,000 candidates. Pre-ranker scores each in under 20 milliseconds. Heavy GPU ranker runs multitask inference on 200 candidates, about 100 milliseconds total. Re-ranker applies diversity and policy rules. 15 videos stream back to the client. Total round trip, under 200 milliseconds. This is why TikTok's feed feels instant even on 4G. The heavy ranker does not predict a single engagement score. It predicts 8 signals simultaneously using separate output heads on a shared model body. Each signal gets a learned weight. Video completion rate carries the highest weight. TikTok's research shows it is the strongest predictor of satisfaction. Like probability, share probability, comment probability, replay probability, and follow probability add positive signal. Not interested and report tap predictions subtract. The final score is a weighted sum across all 8 heads. This multitask approach means the model cannot be gamed by a single metric. A video that gets likes but gets skipped at 10% completion still ranks poorly. That is exactly the design intent. Here's the infrastructure problem that is just as hard as the ML. A user's watch completion rate for cooking videos in the last 5 minutes changes after every single video. The feature store must reflect that in near real time. Every user interaction event hits a Kafka topic. A Flink streaming job consumes it in 10-second windows. It computes aggregated feature updates. For example, user cooking watch 30-second count +1. That update writes to Redis with a 2-hour TTL for session features and a 7-day TTL for medium-term features. Static features like demographic data live in a columnar store updated daily. At inference time, the feature serving layer reads from Redis in under 50 milliseconds. Miss that window and the model is recommending based on stale interests. Most engineers build their first recommendation system the naive way. They score all available content with one big model. They rely on explicit likes and follows as signals. They update user profiles in batch jobs overnight. They optimize for a single engagement metric. The result, cold start takes weeks, popularity bias dominates, long-tail creators are invisible, and the feed feels stale by morning. TikTok's production approach flips every one of these decisions. Cascade filters reduce inference cost by 5 orders of magnitude. Implicit signals, watch completion, replay, swipe speed, are richer than any explicit signal. Real-time Flink pipelines update features in 10 seconds. Multitask learning prevents single-metric gaming. This is the gap between a recommendation toy and a recommendation engine. A pure ranking system creates a filter bubble. It only shows what it already knows you like. New creators never find their audience. Your own interests never expand. TikTok solves this with contextual multi-armed bandit logic in the re-ranking stage. Think of it like a casino with 1,000 slot machines. You know some machines pay out well, but you keep trying unknown machines occasionally because one might pay out even better. TikTok injects exploration candidates, roughly 10 to 15% of the final feed, chosen from content clusters the user has not seen before. If the exploration candidate earns high completion, the system promotes that cluster. Spotify uses the same mechanism for Discover Weekly. Netflix calls it their exploration policy. It is the mechanism that turns a recommendation engine into an interest discovery engine. YouTube published the most detailed public documentation of a production recommendation system, their 2016 and 2019 research papers. The architecture is strikingly similar to TikTok's. 2-stage pipeline. Candidate generation followed by ranking. Multitask learning predicting watch time, likes, and survey satisfaction simultaneously. Deep neural networks with user watch history as sequential input. YouTube's ranking model predicts expected watch time, not click probability. This is critical. Click probability optimizes for thumbnails. Watch time optimizes for actual content quality. YouTube made this shift after discovering clickbait thumbnails were destroying long-term retention. TikTok's completion rate weighting solves the same problem. Netflix's Cinnamon system uses the same multitask framework, simultaneously predicting play probability, completion rate, and thumbs rating. The pattern is universal at scale. TikTok's For You page is the most sophisticated real-time recommendation system in production today. 4 decisions make it work. First, no social graph. Pure implicit interest signals replace explicit follow graphs, solving cold start from interaction 1. Second, cascade ranking. 4 progressively expensive stages reduce 5 billion videos to 15 in under 200 milliseconds. Third, 2-tower architecture. Pre-compute video embeddings offline, compute user embeddings at inference time, retrieve with ANN in under 10 milliseconds. Fourth, real-time feature freshness. Kafka plus Flink plus Redis deliver signal updates in under 50 milliseconds. Every major platform, YouTube, Netflix, Spotify, has independently converged on the same Cascade plus multitask pattern. That convergence is your signal that this architecture is correct. TikTok did not win on content, it won on infrastructure. The For You page is a distributed systems problem disguised as a social app. Next video, how Spotify's Discover Weekly generates 30 million unique playlists every single Monday morning, at scale. If this breakdown was useful, subscribe. New deep dives every day.